So we have basically two demos in this room. Over here we have an infrared demonstration. Now we looked at some thermal cameras in the classroom, but thermal looks at the wavelengths that humans put off, which is about 10,000 nanometers. Can you see 10,000 nanometers? Y'all remember what you can see? Between about blank and blank?
4 to 5.
Well, 400 to
425.
700 nanometers. Alright? So that's what you can see. Now, that doesn't mean everybody's vision just stops at 400. Some people go a little further past. Some people can't quite make it that far. But about 400 to 700 nanometers is what we can see. Now, what we have here is we have two cameras. Okay? These are more or less just regular, they're old, but they're just more or less just regular video cameras. Okay? And just like any digital camera, they have a chip inside there, and I'm not really going to explain all the math and stuff behind this, but basically what's happening is when light comes in, it strikes the CCD chip, and it lights up different areas of it, and it allows it to make a picture. But the thing is that the chip has no idea what the color of the light is. It just knows, like, hey, some light fell on this area. It uses a mathematical algorithm to go back and color in the chip. Color in the picture. So when you're looking at a picture that you've taken with your digital camera, that's what it is. It's light has come in and the camera has guessed at what color it should be. Now, most of y'all have used a camera before, yes? At least one of you. Now, the thing is when you look at that picture, does the colors usually match what they should be? Or is it just completely wrong? It's usually pretty close. It's a pretty good guess. But what's interesting about that chip is it's not like our eyeballs. It doesn't have a range from 400 to 700 nanometers. The chip actually has a much greater range than that. Now, it depends on the manufacturer and all that stuff. But it can actually see light beyond what we can see. You can see ultraviolet and infrared. Now, it has a filter on it that will filter out the ultraviolet and infrared because we can't see that, so we don't want that showing up in our pictures. Because that would make things look, let's just say, incredibly wrong. So, what we have here is we have two cameras. This camera here, we'll call it our control. Our control is just a nice, normal picture. So what we're doing here is we're going to run this camera through the projector and you'll see what the camera can see. So this will be our control. We'll look at it in the light, we'll look at it in the dark, and we'll see what we can see. Okay? Then we will switch to this camera over here. This camera, as you can see, is exactly the same as that one, but I've removed that little covering over the CCD chip so it can take in more light, specifically infrared light. Now this is near infrared. It's not like thermal. Like we said, thermal is about 10,000 nanometers. This guy is going to take in about 800 to 900 nanometers. It's a really close to the visible part of the spectrum. Okay. So let's start off with this guy here. So I've got this guy booted up. It's looking over there. Look at that. Look at that pretty little bird it can see. Y'all see that? Let me focus in on that bird. Yeah, I guess that's as good as it's going to get. So, does everything look pretty normal there? We're okay with that? Nothing too scary? Y'all want me to pan over the audience now? No? Okay. Well, let's go ahead and try with the lights off. Yeah. Turn them off. Yeah. Yes. Now look at that bird. Wow. Beautiful bird. You can't really see. I mean, it's dark in here, so again, you can see. I mean, you can kind of see me a little bit. The bird's still right here. It's kind of still there, but there's just not enough light to see. And remember, we talked about illuminated objects and illuminated objects. Luminous objects create their own light. Illuminated objects reflect light. So obviously, that needs to reflect light, and it's not doing a whole lot of reflecting because there's not a whole lot of light in here. All right, so let's go ahead and bring the lights back up. So, let's switch cameras. So that was our control. That's what things should look like. So let's go over to this guy that's been modified just slightly. So now we're looking, okay, we still see our nice pretty bird there. Let me try to level that out. This camera is a little broken. So here we see the bird. Does anything really look any different? Can anybody tell any differences here? I mean, it looks basically the same. But this one is picking up infrared. Now, is infrared the majority of light in this room? No. Matter of fact, do these lights put out infrared? Not really. So, most of the light we see in here is visible light. So let's go ahead and turn off the lights and see what we can see. Oh, the camera's dipped down a little bit. There we go. Now I can actually see a little bit. I mean, it's not great, but I see a little bit more of that bird. So what that means is this guy can pick up infrared light. That means there has to be infrared light being produced somewhere. So the question is where is this infrared light coming from? It's certainly not the lights in this room, because they're all off. Does anyone know where this infrared comes from? I'll give you a hint. Yes, the window. Now we have the windows, they've got the shades drawn, we've got these pieces of paper over them, but if you're looking through this camera, that's a lot of light still getting through. Now the thing is most of this is not visible light, this is infrared light. Okay? Infrared just comes right through that stuff. So that's why we have enough light to seemingly see stuff over here. Now again, it's not that bright, so I wish I just had a bit more light. Can we turn on the light for a second here? Alright, so I want to draw your attention to this guy. This is an infrared spotlight. And a lot of security cameras that are around like buildings and houses, people will put up cameras, but then oftentimes they'll put up spotlights that look like this, or the cameras come with lights that look like this. They produce infrared light, near infrared light. This one produces about 850 nanometers. Can you see 850? No. But it's pretty close to red, and so when we turn off the lights here, you'll see that it's glowing red. Now, it's not glowing red right now, because this has a little sensor on it that it doesn't turn on when there's light. And the whole point of this is, like, if you had cameras outside your house, they could shine down, and they could look at people, but the people wouldn't realize they were on camera because they wouldn't see any light. All right? So let's take a look at what that looks like. Go ahead and kill the lights again. So can y'all see that this looks a little red? When you're looking at my spotlight here? Y'all see them? Now, what some of you may have noticed is that as I panned around the room, this actually got a little bit brighter over here. So let me go ahead and shine my little light over here. This isn't just like a little light. This is like a floodlight. But the thing is when you're looking at that corner, can you see anything? No. But you can see it through the camera. So I need some shadow puppets, please. You make some shadow puppets over there on the wall? Yeah. I thought you said you could make shadow puppets. Make a bunny. Here's a bunny. So I want y'all to see this here. Y'all see how she's making shadow puppets? Y'all can clearly see it on the camera, right? But if you look over there on the wall, do you see a shadow? No. Because there's this infrared light, it's going out, and it's bouncing off the wall, and the camera's picking it up, but you can't see it because your eyes don't pick up infrared. And so even though this is near infrared, just right next to what we can see, we still can't see it. Everybody okay with that? Alright, so now, I'm going to tell the ghost stories. Once upon a time, all of
the children failed their physics class.
Thank you.
All right, so let's go ahead and turn the lights back on.